Awesome. Well, today we are going to be talking about Slackbots. More importantly, how we can have Slackbots understand natural language, like the language I'm saying now. Instead of just /remind for set a reminder, more of, hey Slack, can you remind me to do a thing next week, and have it understand that sentence. Before we begin, I want to introduce myself. So my name is Chris Marfia. I'm a senior consultant at Darty Business Solutions. Why I'm giving this talk? Because I build Slackbots, and I've been doing it for about 2+ years. So since I first got introduced to Slack at a previous job, I've been building bots. From bots that were helpful to bots that just trolled other people, until Slack removed some features that allowed bots to talk to other bots. But today we're going to try to build a helping bot. But before we do that, I would like to, let's tell a story. So once upon a time, there was a team. That team is oddly everyone in this room right now. And what we are responsible for is maintaining a large code base and knowledge base, where that knowledge base is a bunch of entities that are characterized and classified by other attributes. And we are wanting to share that knowledge with the world. We're tasked to share that in a way that we see fit. So for our use case, we are going to use Slack. We're going to make a Slack bot that allows anyone that can add a Slack bot to Workspace to add the Slack bot and be able to query it for the information within. That information and those entities are Pokemon. So we are going to be building a Pokedex. More importantly, we're going to be building something called a Slackadex. There's a lot of Pokedexes out there on Slack, but we are going to be trying to build a unique one. More of a who's that Pokemon. So instead of using images to define the Pokemon, we are going to be using characteristics. So at Slackadex, who is the Pokemon that appears before a natural disaster? That's not an image, it's more of describing what its characteristics are and a little bit of its description. That is also my favorite Pokemon, if anyone knows who that is. But before we begin on that, we have to kind of think of what are our roadblocks? What are the things we need to do to accomplish this task? First on that list is our users. If anyone's built a Slack bot before, you have to kind of understand that you don't know your users, and you can't really know who they are. You don't know how they'll speak or how they'll talk. You don't know if they misspell something, what their grammar is, things like that, if they speak in different languages, and you have to handle those cases. You also know that the text or the medium for them is text, so you kind of limited their user experience, but you still have lots of variations with text. Next is the number of Pokemon. If this was not Pokemon and it was like a FAQ or something else, you would have still a large number of things. So you don't want to write logic around every single entity in your database. You want something to be able to handle that. More importantly, text processing is a huge roadblock. So we're going to be building a Slack bot that can process text, which you have to process natural language, and natural language processing is a very hard and difficult thing to do. And today we're going to be trying to work through how we can do that. Next is handling updates. If you're familiar with Pokemon, every time there's a new game or a new season, there's a new generation, and then they add like 20 more to the list. And they maybe add something to a future generation, or they add something to the previous form, like a baby version. And so you have to be able to handle those updates and have the system that you're building not be dependent on every single Pokemon that gets added, but be able to just point the thing, add a database, and have it just work. The last two are kind of tied. Time is going to be during this talk. So we're going to be building this while we're talking. Probably the second half of this talk is more when the building will happen. And MVP-wise, we're going to limit the scope to, we're going to say at Slackadex, here is a description, give me back a Pokemon to it. But there's some edge cases that we will walk through as we do that. But we're going to limit it to just handle the bulk of it and not so many of the edge cases. For instance, if we say a sentence and it could mean 2 different Pokemon, instead of trying to narrow it down further to one, we'll just give the user, did you mean one of these? And we'll handle it from there. So that way we're trying to get out something quickly, and then we can iterate over it to improve the model later on. The goal is to get something quick for the MVP. If we focus back on text processing for a second, this is a very hard problem to solve. If we imagine that this is us above the clouds, every one of these buildings, every peak you see here is a different avenue for you to go down to try to learn how to do natural language processing. Should you like try to get into all of these different things like neural nets. Should you do that first? Should you choose this algorithm or that? The problem you run into with like machine learning in this case is when you pick one path, you'll keep going down there, and it might be hard to get back above the clouds. So we want to find a way where we can just take a deep look, do something quickly, and get a return on our investment. When building UIs or anything like web-focused, you can actually change something in the browser, it appears, you're happy or you're sad. With natural language processing or machine learning, you tweak a bunch of numbers and you wait and hope it works, and then you tweak a bunch of numbers. You don't get that instant satisfaction. So we want to try to take a shortcut. And this talk is going to be, how do we take a shortcut to get that satisfaction? So then we can focus on learning more about what's actually happening and what are the better versions of that. So instead of looking at this, why don't we look at it from a different point of view? First, we were looking at it from the top down, trying to look at the clouds. What if we look at it from the user's point of view? What do they actually see? The user's point of view is text. Doesn't matter how it gets into Slack, it's just text. So it could be someone does voice to text, they type it, they draw pictures, and it turns into text, what have you. It's text that we worry about. So in this case, the user will type in some use cases. At Slackbots, who is the Pokemon that appears before a natural disaster? At Slackbots, who is the name of the baby electric mouse Pokemon? At Slackbots, who are the legendary bird Pokemon? These are the 3 use cases you have. They have very specific differences though. The first one's looking for a very specific Pokemon based on its description. Second one is looking for a generation of Pokemon, but the first evolutionary form. And the third one is looking for an array of Pokemon, so it's looking for multiple. So that's context that you can have in your head from all the knowledge you have, but to a computer, it can't really process this. It doesn't have all that knowledge we've built over years. And more importantly, it has at Slackbots in the front. Because this is an MVP and we want to get this out quickly, we want this to be public, we don't want your bot to be answering every message. If you install this in a corporate workspace, by default, Slack will respond to every message it gets. So let's say if it's in a channel called General and there's 5,000 people in that channel. When someone's asking, hey, is prod down? You don't want a bot to say, did you mean Pikachu? It will get uninstalled very quickly. So to prevent that, and for the purposes of this, we are going to prefix everything with at Slackbots, and then in our app, we will ignore any message that doesn't have a mention to our bot inside of it. Security reasons, there's other ways to do that, but we want to do this quick. This is what the user sees, but this isn't actually what we see. As developers, or more importantly, the computer, or the bot, it sees this. The difference is at Slackbots is turned into its actual user token. So user tokens are defined by the brackets, and then you'll have an @ sign and then a token. If the token begins with a U, it's a user. If it begins with a G, it's a private group or a private channel. If it begins with a C, it's a channel, and then so on and so forth. There's a lot of other different things. So you can lock down your Slack bot for talking only in direct messages, or only in this specific channel, or only to these specific people. So you have that power, but we're just going to lock it down to our bot. For our use case, our main problem we're trying to solve is text processing. For that, we don't really care about the Slack token unless we're trying to limit how many messages we're talking about. So I'm just going to remove that noise. We can keep in our minds that that's still there, but for the point of text processing, we're just going to remove it from the slide. Is this still large enough to be processed, or small enough? Or can a computer just even process this? When you say, who are the legendary bird Pokemon? You might in your head be processing who those are, but a computer will see that as a string. Can you give a string to a terminal or a string to like any program and have it know what you mean automatically? Chances are no, unless it has context. So in order to do that, we have to build context. We have to build context incrementally. How our brains work. When we read text, we chop up what we're trying to process into smaller pieces and try to make those connections ourselves. So that's what we're going to do. We're going to take our text and chop it up into little pieces. And to do that, we are going to use a tokenizer. A tokenizer is an algorithm that you can use to take a string and process it into an array of tokens, small strings. There's different tokenizers out there. We're going to use a word tokenizer today. It cuts it at white space, so every white space will chop it off. There's also character tokenizers. So if you're building like a parser or an interpreter for a language, you can chomp character at a time. There's also sentence tokenizers and paragraph tokenizers. If you're trying to read like a book, you can chop it into smaller parts. Punctuation tokenizers are similar to word ones, but in the case of like a conjunction where you have can't, it'll chop it at can apostrophe T if you need that tense. And then lastly, any kind of pattern or regex could be turned into a tokenizer as well. A tokenizer by default is just something that will take a string and put it into smaller chunks. So if we look at our text, let's apply that word tokenizer to it. Now we took that sentence and we chopped it up into little pieces. This is easier for the computer to understand, but we still have some issues here. This is a lot of words and a lot of variations for a computer to try to build that context. Computers are smart in the sense where we can make them smarter than us. We can make them in the case where we can give them more contextual meaning, and they don't have to understand like every language's nuances. So in the English language, there's a lot of nuances between words and lots of variations. In particular, like the word appears up there. You can have appear, appears, appearing, appeared, and so on. There's multiple tenses. For our use case, we don't really need to worry about those tenses right now. We might have to later, but for an MVP, we don't need that. We just need to know about the word appears, or appear. In that case, do we want to write edge cases for every one of those variations of every possible word that can exist? Probably not. So we should reduce those variations. The warning there, though, is the more variations you reduce out of the text you're processing, the less accurate your solution will become, and the less correct it'll become at the end. But sometimes that's okay. In this case, we're just trying to shrink it down so we can give them a Pokemon. The word appear doesn't really give us any meaning to Pokemon, so we're just trying to shrink it down so we can process it. To do that, we are going to use something called a stemmer. A stemmer is also an algorithm that allows you to take words and bring them to their closer root word called a lemma. That root word is the root word for the language you are in. That's very important because if you are processing English in the US, the lemma might be different than English in another country. So every country has its own lexicon, every country has their own root words. Sometimes, even if the languages are based off of the same common language, the root word might be different. And then that's why when processing text, you really need to know what language you're processing for so you can really understand it. There are many different stemmers out there. We are going to take the more naive approach today, just because we want to move quickly. And the algorithms that are the naive ones are available in the library I'm using. That's kind of why we're doing that. Basically, the naive approach is just chop off the inflectional prefixes and suffixes. So like ing, s, ed, it'll just cut those off and just give you the root. But here be dragons. You have to be very careful because the root word that you might think is the root word is not the root word for the language. In this case, the word lazy. So lazy and laziness get converted to lazy with an I instead of a Y because the root word for things that end in Y is an I. You can't really hard code these because then you might not be paying attention to like these like subtle nuances that will cause you lots of grief and pain. So you have to like be careful when doing this that you do the root words on both sides and do the compare and you're not hard coding things.
Now, is this what you're doing specifically? This conversion?
Yes, so we're going to walk through how to do this conversion. There's a package that we're going to use. It's an NPM package that will actually walk through and do most of this. And you can see how the different algorithms work. But today, we are going to use something called a Porter stem. It is one of the simpler ones, and it is the one that doesn't require you to do anything for it to work. So that's why we are going to use it. So if we have our array of tokens again, we just apply that Porter stem. Not much changed. If we go back and forth through them, basically the S gets taken off of the appear, the E gets taken off the before, natural removes the AL, disaster takes away the ER, electric takes the IC away, mouse takes the E away, baby and legendary turn into an I instead of a Y, and then R drops the E. So the very subtle differences, but we just removed a ton of complexity with our processing by chopping off all variations. This is just 3 examples. If you imagine like how many messages happen on Slack a day, and if someone's messaging this bot, we just chopped off a lot of variations that we don't have to care about at the moment. Eventually, if you want a more accurate model, you might have to add them more in because you might need to know the context of, is it appearing right now or has it appeared? But for us, that context doesn't matter, so we cut it out. But we can do one more thing. Those words that I cut out, were they important? They're important in the English language because like you need context. You need to be able to talk to other people in a way that sounds coherent. But to a computer, you don't need that. To a computer, Pokemon appear, nature, disaster. That's very contextual, it's very short, it's to the point, it's void of variations. A computer can understand that. Saying, who is the Pokemon that appear before a natural disaster? There's so many filler words in there that a computer doesn't need to know because they don't add context to the sentence. They just make the sentence make sense. So we can just chop all those out. So if we think about our original sentence of, at Slackbots, who is the Pokemon that appears before a natural disaster? Pokemon appear, natural disaster is very short. It's 4 words that have a lot of context, and you can process that quickly. And that is the important part of text processing. Knowing the word Pokemon still in here, the reason for that is the words that we are using are English words. The word Pokemon is not a real word. It's a word that's been created, but it's not part of the actual language, so that kept in here. If you want to actually remove things or stem words that aren't real words, you can set up custom lexicons to do that and say like, all of these variations mean Pokemon. But for us, we don't really care about that because we still need the word. What if later in V2 of this bot, we wanted to be able to know moves or games or locations and things like that? So adding that, like, in what game did this appear? Then game is important context versus Pokemon. So that's why we're keeping it. But I have to think, is there something out there that already does all of this? If you imagine all of that work that you have to do that little bit of text processing, to take this string of like 50 characters and shrink it down to 4 words, that's a lot of work. It took me 17 minutes to talk about all of that work, so it's a lot of work. So is there something out there that can do all this for us? More importantly, is there something out there that can do all that for us and give us something else? The something else I'm talking about is probability. All we have done up to this point is shrunk the data set we are working with, but we don't actually know if it compares to anything yet. We haven't marked it like this sentence is this Pokemon. So we need to be able to define the probability between those two so we know which Pokemon they're talking about. And the way we can do that is a classifier. So this is my shortcut to get into natural language processing. I tried many different ways, but all of them required a lot of upfront knowledge and going down those buildings and trying to figure out, okay, am I too deep? Now that I learned this thing, it opened 4 more doors and I have to learn all of those. A classifier is just, I need to know what a tokenizer is, I need to know what a stemmer is, and that's it. It does everything else for me. Once I figured this out, I can go in deeper and find out what are all those black boxes I don't really understand. But I want instant gratification, so I'm going to use this. There are 2 main ones I'm going to talk about. One is the naive Bayes classifier, and the next one is logistics regression. The naive Bayes classifier is the one I typically use. We are not going to use that today because it requires a larger data set to actually be more accurate. Every one of these algorithms vary drastically with the data that you have. So you have to pick one that works with your data. For the demo I'm going to do today, I did not add every Pokemon. I added about 20. So that's too small of a data set for this classifier to process. It was giving me wrong results because it couldn't process that data. So we're going to use logistics regression, which is more accurate with less data, and it is not actually a classifier. Logistics regression is a statistical model that's used for modeling probability, and you can use it as a classifier. And because it's directly related to modeling probability, it can work with any size data set. So that's why we're going to use it today. There's a couple of gotchas that we have to worry about. Classifiers and other models like this need to be trained. So you need to know what the data is ahead of time. Or if it's a learning engine, you need to be able to keep feeding it more data so it can learn and get that context. Like I said when I put those sentences up there, who are the legendary bird Pokemon? You might have instantly got that in your head because you've maybe played the games, watched the show, heard people talk about Pokemon. We had that context. We need to build that context over time into our program. So that is why you need to train it with information, just as we have been trained. But it is a probability engine, so we can give it inputs, and it will give us an output based off what we trained it with. That output is a number between 0 and 1 because it's a probability of how it matched that. So we need to put in a threshold. We need to hold up the floodgates. If we have trained this with 500 Pokemon and we give it a sentence and we expect something back, it's going to give us the probability that the sentence we fed it matches all 500 Pokemon. We don't want it to return every Pokemon when we're only looking for one, so we need to be more accurate and say, give me the Pokemon where the probability of this string matching that is about 90%-ish. We don't want anything that's 0%. So this is the one number that you need to tweak and train when working with probability, because like this is the only mathematical part of this. It's just working with that and your data set. As your data set changes, this threshold will change as well.
How much does that number vary?
Drastically depending on your data set. So when I had a data set of about 10, I can do the probability about 60%. When I had a data set of about 20 to 50, I needed to increment it up to 90. The more data you feed into it, the more differences you get out of them. But that's just with the logistics regression. The Bayes classifier, like it was down to like, when I trained it with 10 things, everything was at 50%. Because like it didn't have enough data in it to like find the differences between them. There are some drawbacks though. First drawback is you need to know your data ahead of time. So you need to have something to train it with. While you can train it on the fly to have it continue to learn, you need something to initially train it with like any other statistical model. If you're doing like image classification or text processing, you need something to educate the thing to do the processing for you. That's the main one. There's one drawback of the package we are going to be working with today, which is the data that you train it with needs to be in numeric order if you are working with numbers. In my case, my indexes are Pokemon IDs to some characteristics about them. There is a bug in the package that I found that if you trained it with the numbers not in the right order, what you'll get is you'll get the index of the wrong Pokemon. And that is a bug that was in this package. It's on GitHub. Took me a long time to figure out. So if you run into those issues, you might want to check how the algorithm's working under the covers, because I had to do that as well. But let's get into the how. So that's what we are going to do today. The how we are going to do it. Well, we're going to use Node, JavaScript. For this, I have version 10 plus up there because that's what my original bot was made in, and we're only going to use 3 packages. The first package is the Slack real-time message API. The second package is the web API, and the third package is natural. So the real-time message API. In Slack, if you want to talk in real time with anybody, which means if someone's typing in a channel, you want to respond to them in the channel, you have to use the real-time message API. It is what fires off of that. It's basically just an event engine. So every time an event happens in Slack, it'll send an event to an event emitter in your app. You can do on message, on ready, on authenticated when someone joins a channel, when someone joins Slack. If any real-time event happens inside of Slack, then you can listen to it and you can talk back. You can only talk back though. So talk back means only text. You can even send like, hey, I'm processing your thing by saying it's typing. But if you have to do anything more than that, the real-time message API is not built for that. So let's say someone sends you a message and you want to send them a message that only they can see. Well, you have to use the web client for that. If you want to get more context out of it, let's say they send you something, but your bot's confused. It doesn't really know how to process it. So you want to ask them a question like, did you mean this or this? Maybe in a drop-down or a button. You have to use the web API for that. Anything that is not listening to an event or sending text back to a channel, you have to use the other API for, which is why we're bringing in the web API. We're going to be sending a message, doing some pretty attachments to attach Pokemon to it, and we're also going to be doing some other things there as well. Slack offers lots of different APIs. You can get lots of data from them. So you can use buttons, you can use drop-downs, you can have dynamically populated drop-downs. So as you pick one, it can populate another. You can do modals now and a bunch of other cool things. For us, we are just going to worry about text today. But if you need to have an ongoing conversation, you probably need to use the combination of the two. because every message sent in Slack is its own message that has no reference to the message before. So if you're just processing text and only text and you're talking back and forth, like you and I can talk in Slack back and forth and we have the context of what's happening in the thread. The bot does not have that context. So you would need to have some way of knowing what the last message was sent by this person to me. And you can do that with the web API by hiding data inside of your callbacks. And lastly, we're going to talk about a package called Natural. Natural is the natural language processing package we are going to be using. It's more than that. It's actually like a really good defined machine learning library for Node. I wouldn't probably recommend Node for all machine learning things, just because there's a lot more packages in other languages. But for Node, this is a very, very well-created package with lots of different libraries. And you can do a bunch of different algorithms in it, and it's pretty full-featured for what you need in small use cases. So with that, we are actually going to dive into the code. My GitHub link's on here, so if you want any of the code or this presentation, you can look at the screen. It's at github.com/cmarfia/slackbots from commands to conversations, the name of the talk today. So with that, we are going to dive over into this. Cool. Can everyone see that? Awesome. So we're going to only be working with 5 files today. The first two are not anything we're going to code in. They're more of things I'm just going to explain as we go on. For the purpose of the live demo, I did not trust myself from getting rate limited by the Poke API, so I just copied things down to a local JSON file. Bad things have happened in the past when I've done that. So the structure I just need to explain a little bit because it's data I've processed beforehand. What generated this was code, but it's not in this repo. But I am good to explain it as well. So basically, I hit the Poke API, which is a public API where you can get Pokemon data from, and you can just iterate over it. I did about 50 Pokemon-ish. I might have taken some out for this demo, but I got the name of the Pokemon's ID, the latest sprite. So every time there's a new game or generation, there's more sprites. So I just grabbed the latest one so you can show a picture of the Pokemon. Grab the Pokemon's primary color just so I can be fancy in Slack. And then got a list of documents. That's the important part here is that list of documents. What I did was when I hit that API, I scanned the description, scanned their evolutionary tree, scanned their color, scanned their type, scanned a couple other things, and just grabbed chunks out of it. So I just chunked the strings and made a couple documents. So that for every evolution, it's evolves to or evolves from. Got the colors in there, so blue, green. It's a starter because it was deemed a starter. And then I just grabbed descriptions from the multiple generations, like it's a small dinosaur with a plant. And then grass type, first generation starter. So I just grabbed a bunch of words, took out any filler words, so that's why these really don't make sense. But they work enough for us. They are the sentences we are going to compare to. And then like go down the list. So for Ivysaur, it evolves from Bulbasaur and evolves to Venusaur. If you do check out the repo at all, there are some Easter eggs added to a couple of the Pokemon just while I was playing with this and having fun, but we can find those later. The next file we are going to look into it's a simple DAO file I created. It's just a way for us to get Pokemon in and out of there. So it brings in that JSON file. If this was a real DAO, it would probably pull that from a database or somewhere else, but it gets the data. Get documents is a poorly named function that will just return all of the Pokemon. The next function is get by ID, which will accept a Pokemon ID and then find that Pokemon and return it. Not production ready, but it works. The next file we are actually going to look into is the index file. This is everything we need to start the Slackbot. Nothing else. So this file is only going to be for starting the Slackbot. We bring in some imports, the real-time message API, the web API. We bring in our classifier, which is the next file we are going to look at, and how we can train our classifier. We bring in our DAO for how we're going to get Pokemon out of it. And we bring in a function called process message, which is the last file we are going to work with, which is how we're going to process the text that we get on every message. And we're going to kind of go through these. I have to-dos in here. So the first thing we need to do is to do one. We need to create the clients. So I'm going to go in here, do a shortcut there so I don't type it all. We are going to just return the web client and the real-time message client. The only thing you have to do is send in the Slack tokens, and these are created. The important thing to note is they're not authenticated, and you can't do anything with them yet. They're just creating JavaScript classes and objects, so you can't really do stuff. So next we have to actually authenticate against them. The first one we're going to authenticate against is the web client, and we're going to do that by trying to get our Slackbot user so we can do some cool things. So if we look at that, the first thing we're going to do is await the web auth test function. If you're familiar with Slack, these actual packages do is just alias the REST endpoints. So web is just, this is the RESTful endpoint, auth is the auth controller, test is the post method called test. And then we are just calling that. Same with info, so web/user/info is a post that accepts that as a body. So you don't actually have to use these clients, you can use the REST endpoints, but these are all wrapped. And if you're a fan of TypeScript, all of these are TypeScriptified, so you can actually use those as well. So first thing we're going to do is do auth test. This function actually will authenticate you. So this will call Slack, get everything working, send back your bot user ID if you have one. So if this doesn't work, then the web API will not actually be authenticated. Next, we take that bot user ID, and we call the users to get information about that user, which is we just want the name of the user. We're going to use that mainly so we can just print in the console to make sure we authenticate against the right user. If you're swapping different environments or swapping different Slack workspaces, you don't want to log into the wrong one and wreak havoc. So this is just a sanity check. And then the last thing is we're just going to return those things so we can use those later on. The next is the meet. So this function gets run when the file loads. So what is it actually doing? Well, it's calling the create Slack clients function that we just implemented, getting our Slack token from our environment. So if you do use this code, you'll need to put that in your env for this to work. And then you can follow the steps at api.slack.com/apps to figure out how you can create an actual app. And then the only thing you have to do on there is once you create your app, there is a add bot user little button to it. And once you add that, it tells you what workspace you want to add it to. You add it to the workspace, it'll give you a token. Next, we call the get user that we just implemented as well, passing in the web client, and that'll get us our bot user. So at this point, we are authenticated against the web client. We call our Pokemon DAO to get all of the Pokemon, alias by horrible function name get documents. So next to do, we have to train our classifier. So this is the part where we have to make the classifier understand context. So if we add that in there, we're going to implement this method in a minute, but just know in our classifier file, there is a function called train that accepts all of the Pokemon we have. Next, we should actually listen to some events. We want to use the real-time message client to listen to things, so why not do that? So we're going to listen to 3 events mainly. On message, and then we are going to call that process message function, passing in the user, the real-time message client, and the web client, so we can actually do that processing. Next, we're going to listen to authenticated. This is to make sure that we authenticate correctly. There is a distinct difference between authenticated and ready. When you are authenticated, you can't talk back to Slack yet. So Slack says, yeah, I know who you are, you're good, but you're not ready to communicate back. So you can't actually call any methods to write to Slack on authenticated because Slack will still deny you because you haven't fully done all the handshakes. It just knows you're real. So on ready is when you can talk back to Slack. So if you want to say, hey, I'm a bot and I'm alive again, you can do that on the ready. But you can't do that on authenticated. But we're just going to use those to log to the console so we know those events happened. And then lastly, we need to actually trigger all of these things to happen. And to do that, you just call start. It's an async method that it starts and it just runs indefinitely, listening to all of these messages in an endless event loop. And then when the app dies, it'll die. So that's all we had to do to get a Slackbot up and running. It's 39 lines of code with a bunch of comments, but that's all we need. So Slackbots are fairly simple. And there's a lot of extra stuff in here as well. if it's only 39 lines of code to get Slackbot up and running, how hard is it to implement that classifier? Because text processing was the hardest thing on our slides to actually go through. So that has to be the hardest part. Well, let's walk through this. We import our natural package, which is that machine learning package with all those fancy algorithms. We create a classifier using the logistics regression classifier. Notice we don't have to pass anything in. It magically works. So with this package, its default is to use a word tokenizer and a porter stem. So we don't actually have to do anything. It just does all of that by itself inside of its magical black box. And then if we want to say, hey, we're actually processing Spanish, we can pass in a different tokenizer and a different stemmer to process Spanish words instead. But for us, and we're just using the English language in the US, that we don't have to do anything else. All the ones I messaged today are available in this package. The next one is we have to do our next to-do, which is train this classifier. So right now we just created it and it doesn't know a thing. It's like a newborn. So how can we get it to have context? Hopefully it won't take years like it does for us. It'll take a couple lines of code. So first thing we're going to do is we're going to loop through all the Pokemon we have. Then we're going to pull out documents and ID. If we go back to our Pokemon.json, documents is the list of just strings of random context, and the ID is the Pokemon ID. And then we're going to loop through each one of those documents and add it to the classifier. The important thing is now every Pokemon in that list has 5 documents attached to it. That means every time we add a new Pokemon, we're adding all of those to the classifier. So we're constantly training it. It's not we trained it once per Pokemon. We gave it lots of context over time. When you're trying to learn something, it's not that you read a big book on JavaScript and you understand everything in one flash of looking at the page. You build that knowledge over time by reading it, reading more chapters, reading things again. So that's what we're doing to this. We're training it with more context for every loop. The more data you have, the more accurate it'll become. And lastly, we call a method called train. You have to call train for it to actually be trained. The benefit of this is you can keep adding documents to the classifier and keep giving it more context and then train it in intervals. So if you want a bot that learns over time, you can use a classifier instead of like a neural net to try to do it in an easier way. And you can just keep giving it more documents to train, and then either when it's at a set interval or when there's not a lot happening in the bot, you can retrain the classifier to make it smarter. You can also copy that down. So let's say you train this with 15,000 things and it's ginormous. You don't want to have that living in memory the whole time because that would not be good. You can actually save this down to JSON files or save it to a database, get a binary string out of it, and then put that away. And then when you need to start your classifier again, you just load it up, do what you need to do, take it down again. So that way it's not constantly living. But for our case, we're just going to keep it alive. And then there's one other method in here, which is the fanciness about this. So we trained our classifier, but it doesn't do anything. How do we get stuff out of it? We talked about probability. So how do we get that probability out? That's called a getClassifications method. I named it getClassifications because the actual method's called getClassifications. So I wanted to just keep the naming the same. This is going to take in text, which is going to be the actual message sent in Slack, and then a threshold. We're going to default it to 90%, but we can play with that to see what happens. And it's going to do 3 things. One, it's going to call the classifier to get all of the classifications for the string that we gave it. 2, it's going to filter that down for the value. What the value is actually the probability. So it's going to filter down where the probability that this item is over our threshold. So only find Pokemon that are over 90% accurate. And then last, we are going to map this to return us a list of our labels. Our label is the ID we pass in. So basically, return us an array of Pokemon IDs for the text we are working with. And that's it for our classifier. That was 27 lines of code. So if we think about how long it took to actually make our Slackbot is 39 lines of code. And our classifier is only 27 lines of code. We're not even at 100 lines, and we already have a working classifier and a working Slackbot. Let's take the last step and go to here. I'm going to go save all these files. The next one is the process message. So this is every time a message is sent in Slack, we are going to process it with this file. We're going to import our classifier. We're going to import our Pokemon DAO so we can get the Pokemon ID out, and then we're going to do some cool things. For the purpose of this, I just have the code in here for our helper functions. The first one is called title case. We're just going to title case the Pokemon name, simple as that. The next one is called send Pokemon. This is going to accept our web client, our actual message we got from Slack because we need context from that, and that array of Pokemon IDs that we will get from our classifier. It'll promisify that by looping over all the Pokemon IDs, get the Pokemon for that. And then we just have a bunch of Pokemon now. Next, it's going to call the chat API endpoint for posting a message. We are going to post a message as a user. So as user is as the bot user. The message has a channel attached to it. So we are going to send the message to the channel that the person typed into. We are going to do some pluralization here on the message. If we only have one Pokemon ID, we're only going to say, is this the Pokemon you're looking for? If we have multiple Pokemon, we are going to say, are you looking for one of these? So we can just be a little bit more friendly to the user. And lastly, we have attachments, and this is where we're going to actually put the Pokemon. So we're going to loop through each one of those Pokemon and create a Slack attachment to attach to Slack by giving the title being the Pokemon name, the text being the Pokemon's ID, the image being the sprite, and then we are going to have a little fancy border of the Pokemon's color so we can be nice with that. But that's it for sending it. So that's all you need to send a fancy message back to Slack. Let's look at our to-dos. The first to-do is the very important one, which is to make a regex so we only listen to messages that have the Slack index inside of it. So we're just going to make a dynamic regex, take in the bot's user ID that we got from authenticating against the web client, and then make a custom regex only for that. So that gets returned in our process message function, which is actually the last function that we are going to work with today. The first thing is getting that custom regex we did. Now let's use it. We're just going to say any message that does not have the Slackbot's username in it, we are going to just ignore and not process anymore because we don't want our Slackbot being removed. And that's all. The next thing is, if we aren't ignoring messages, we should probably tell someone that we understood them and we are going to listen to them. So we are going to send a typing message back. So if we are processing your message, we are going to tell the person that talked to us that we understood you, we're processing your message, we're typing. This is just a way that you can have it so your bot seems to be thinking about something. And once you send a message to Slack, it'll remove the typing notification. So you don't have to manually turn off typing. It'll automatically do that. And if you don't send a message or forget to send one or you time out, it will eventually time out as well. And the very last to-do we need to do is get those classifications. Whoop, wrong one. So we're just going to call glue classifications and pass in the plain text that we type into Slack. That's all. And then if we get classifications back, we are going to call that send Pokemon function. If we don't get classifications back, we're going to say sorry. That wasn't an edge case that we thought about. Maybe be more descriptive. This is one of the problems with classifiers. It doesn't cover every edge case. So you might run into where the classifier gives you 50 results back or gives you none. How are you going to handle those? That's where you might need to either pick a different algorithm or do further processing to try to narrow down that list. But for us, we're just going to either send you everything or send you an I'm sorry message. And that's pretty much what it is. It's fine for MVP, but we can do better next time. Let's actually see if this works. So we are going to do run start. It's node / source start index. And if we look here, source start index, I'm running the files we just worked with. And we've authenticated as Slackadex, and Slackadex is ready. Cool. So if we go to Slack real quick and say add Slackadex, who is the Pokemon that appears before natural disaster? If I spell disaster right. I'll just spell it again. Did you mean Abdul? So return that one. Let's see about the next one. Favorite Pokemon, by the way. So who's the baby electric mouse Pokemon? Oh, Pichu. And we got the legendary bird Pokemon. So that was minimal work. It was less than, or it was around 100 lines of code. We have pretty much a fully functioning Slackbot, or Slackadex, that'll allow us to query against a knowledge base of Pokemon and then process text for the user. And if we type in something it doesn't understand, it'll just tell us to be more specific next time. So if we go back to this guy. So what do we do? So to summarize, our goal was to build a Slackbot called a Slackadex that was able to process text and do a who's that Pokemon, but based on descriptions instead of images. I think we accomplished that in our time today. The next one, we talked about pre-processing of text. If you need to process text in natural language, you need to pre-process it in a way that a computer can understand it rather than humans. Because in our brain, we do all the things we talked about, but we need the machine to be able to do those things too. So you need to pre-process it in multiple different ways. One is chunking it into smaller sections so the machine can learn over time. That's tokenization. Second is stemming it, which is removing the variations of words. This is only needed if you need to not care about the context or inflections like appears, appeared, appearing. If you just need to know about the word appear, you can chop those off and just remove your data set. And last was my personal shortcut to get into natural language processing, which was using a classifier. Since it was simple to use, it was a limited code, and once I actually got this done, the coding part was actually maybe around 10 minutes. We got through it all. We got something fancy to show on the screen. Now I can dive deeper and learn more about natural language processing, knowing I've at least accomplished something rather than trying to learn algorithms. So with that, is there any questions?
I have a question for just
Yeah.
to make sure I understand the level at which it's working. So I noticed that to get the results, you entered in basically what your base questions were.
Yeah.
If you just entered in like mouse Pokemon, would it still select the correct one for that? Or
We can try.
adjust the accuracy? Like how would you address that?
So just mouse Pokemon. Yeah, it didn't know that one. We can see.
Maybe
Oh.
90% too high, or is that what the factor would be affecting it? Or?
We can go through that real quick. So that was 90%. Let's drop that down to 50. And well, we'll have to restart the bot real quick. So that's where you have to be careful about the threshold. This might get us a lot more than we want, but we will see. So now we got the whole family tree. So that is, oh, I was still in PowerPoint mode. There you go. So the first one, 90%, only got us nothing.
Honestly, that does all apply though, so that's
Yeah.
really what we would want. Okay.
So you just have to play with that threshold a little bit. The more text that you give it, the more accurate the solution will become. Like if I just typed in Pokemon, it'll still give me none. If I put the threshold down to like 1%, like 4 of them have Pokemon in the title, so then those will come back. The danger is like if there's one phrase in here where you'll just get a lot back. I don't actually know which one that is. If I switch to, it won't let me get out of there. I can't go back far enough, but there's a couple phrases that'll just give you every Pokemon on there. But the accuracy is due to how you trained your bots. So if we go back to the code and go in here, so this is all we have for Pikachu. We would need a lot more words or a lot more documents that have the word mouse in it to appear with just the word mouse. So the more times mouse appears in here, the higher the probability that it will return with mouse. Any other questions? Yeah.
For a classifier, do you have to retrain it every time the database, well, the documents change, or we add things to the documents?
So anytime your data model changes, you will have to retrain it. But if it's alive right now and only new data came in, you can just feed it new stuff and then train it just on the new things. But if it's like you need to delete things and you're doing a wholesale data set change, you'll have to retrain it from scratch.
So if it's live and you're feeding in just new data, you can just train it on the new stuff.
Yep.
Is that a long-term solution, or is that just kind of like is there a limited time, I guess, for that, or can that just be the steady state, where it's just like, hey, we're just getting new data, we're just training it on the incremental?
Training is like the length of time it takes to train is very small. So as long as your data set's not like a gig worth of data, you should be fine. The only problem is when it's trained, everything's in memory at a time. So if you like, when the bots I have are like running on EC2s out there. So if you have like an EC2 with only like 128 RAM in it, like you can't really have a giant classifier running constantly, or you'll like use up all the memory. So that's the only consideration there. There are ways to remove documents, but from what I've seen, like removing things on the fly, it doesn't really work that well. But you can tear a whole thing down and retrain the whole thing again pretty quickly. Because you can remove everything, remove all the documents and re-add them all, and it still will be trained with the old data set, and when you retrain it, it'll swap them. So you can do it that way. The only problem is like both data sets are in memory at a time. Any other questions? Well, awesome. Thank you.
I did have one more.
Oh, cool.
I was in the back when you talked about, I think, stateless communication.
Hmm.
And I just missed what you said about that. Obviously, it's stateless by default.
So in Slack, I'll demo it here. So when I said like at Slackadex mouse Pokemon, and Slackadex responded. When I said that again, it doesn't know I said that before.
Right.
Every message is new. It has an ID of a timestamp on it. So you can't build a tree of them. So if you're having a conversation back and forth, like, where are you going for lunch? I'm going to this place. You can't really do that with Slack without like holding that knowledge internally or like knowing those IDs. If you talk in a thread, and we open like threads and we do something like that, what Slack actually returns you is this message, but it has a link to the parent thread. So then you can go down and you can process all messages again. What you can do to bypass all of that processing you need to do again is if you use the web API, what you can do is send one of the interactive messages, which is like buttons and drop downs and things, and you can hide data inside of it. The difference on that is the interactive messages actually need to call a REST API endpoint, because they don't talk with real-time message one. So you'll have to say, I want to display buttons to the user. Here are my buttons. Here's some hidden data. Here's an endpoint for you to call. And then it'll call an endpoint, and then that endpoint will be the one communicating now instead of the actual bot. So bots can be like diverse. You can have the bot be real-time messaging. You can have it be an API that talks with buttons. You can have it be /commands that are also doing APIs. So it's not just one thing. Bots will be built over many different tools. But the context of that is different in each one. So you have to find a way to know context as you're building it. That's why a lot of bots respond with drop downs or buttons, because that's the way for you to get communication back and forth.
Speaking of /commands, is it the same way of implementing them? You just run a special?
A /command would be, you would say what your /command is, and then it will call an API endpoint that you have to supply it. So there's two API endpoints for that. One is called messages, I believe, which depending on what your /command does, you can have it call one endpoint to actually execute the command, and then another endpoint to feed it more data. So if you have like a /command that will respond with a form that will need drop downs filled and things like that, it will call a second endpoint to get that data for that, and then talk to them that way. So if we're creating a slash command or just the interactive ones, you can set up like a Lambda that has an API endpoint on it and just talk that way. You don't need to have a long running bot. For like real-time message client, this thing needs to be alive in order to talk to it. So you can't just have it be in a cold start state. Any other questions? Cool, thanks.
Yeah, so, and that's correct. That was all.
Thanks.